Hello, everyone. Welcome today for the third session in the series of machine learning in Azure. First of all, thanks for joining us today. And let's start the session, just to start on time. First of all, we have a presentation to introduce to the SDK. And after that, as usual, we go to the demo to see how we implement this practically in Azure Machine Learning Service. Let me navigate to the presentation. First of all, my name is Osama Abdelhamid. I'm a technical team leader and solution architect. Today, this is, as I said, this is the third session today to talk about Azure Machine Learning. We already introduced many concepts before in the last two sessions. We are going to elaborate today on the SDK. So if you are a developer or have a background in the development, that will be great because that will help you a lot to get the most benefit of this session. In the first slide, we're gonna recap on what we already explained before about the machine learning steps in general. And that will be very brief, just to allocate more time to the new topics and the new items that we are planning to discuss today. In the machine learning steps, as we said before, we are loading our data set because usually we said many times before that we are trying to solve a real problem with data. We have a massive data around us, and using this data, we can come up with insights or solutions to real problems, which actually can be more innovative than the traditional way of solving problems. So we start from loading the data sets and clean the data, make some transformation on the data. This transformation, we talked about it in the previous sessions, and we mentioned many examples of how we can transform our data. Then we start the training phase, where we are training or fitting our model to this data. And usually we have a bunch of machine learning algorithms we are using to fit our model based on this selected algorithm. And that selected algorithm is highly dependent on the nature of the problem, okay? And after training the model, we try to evaluate this model to make sure that this model is the best fit to solve the problem. And if we are fine with that and we feel that this model is the best outcome that we can get, we can move on and deploy this trained model to start getting predictions and have real use in the production environment for the public users. Then we said also before that when we talk about Azure Machine Learning Services specifically, we have two main parts. We have the set of Azure Cloud Services, okay, which we already explained many of them before, plus Python SDK. This Python SDK is our topic for today. This Python SDK is the way to deal with Azure Machine Learning Service programmatically and make sure that we have enough flexibility to build effective machine learning models, which is not limited to Azure itself, not limited to specific frameworks or specific libraries. No, you have the freedom or the flexibility to build with any open source framework, with any open source library available. You are not restricted if you are working on Azure Machine Learning by any specific things constrained by Microsoft, okay? And we talk also about the training pipeline, and we have seen before how to build in the designer in Azure Machine Learning Studio, how to build visually the training pipeline, and then after we train this pipeline, actually submit this as an experiment and have successful run for this experiment. We get a model, trained model, then we deploy this using inference pipeline, and we already discussed this point before. And for this slide, it summarizes actually the same point we just talked about. You are not restricted to a specific framework. You can bring your own framework, which you prefer to work in your implementations, and you can work with this, continue to work with this framework, you and your team, as usual. So suppose you are working in a company, and this company usually is more most of the time working with PyTorch or TensorFlow for their specific problems. Whatever the library you are working with, you can go ahead and continue using it in Azure Machine Learning Service. Even if you, we are talking also about the Python SDK, you can use whatever you would like to continue your work with, including also scikit-learn, PyTorch, Keras, Chainer, Caffe2, and so on. Okay, this is the most common frameworks and libraries we know about in the market, and this is the widely used things. Okay, and we talk also about the ONNX model, which is open standard format for the machine learning models, which make them exchangeable between the different frameworks. Okay, and eventually, if we have this standardization or this open standard format, we can deploy this to any compute target in Azure, in our on-prem data center, in a specific virtual machine which is running in our data center or so. There is no restriction on where you're gonna deploy this trained model to start getting predictions from it. Okay, this is the point that we want to explain here in this slide. Then we talk about the ML ops in general and how the whole process is interconnected. We start from the left side, from our IDEs or our development tools. So we have a development environment we are building with any tool or any IDE we prefer, like Jupyter Notebooks, Visual Studio Code, PyCharm, whatever. Okay, you can name it. And then once we are building our model, we start moving on to training and testing our model, then registering this model as a Docker image. Then this Docker image, we can take it and deploy it as a service, and this service could be consumed by any application or any mobile app and so on. Okay. Now let's start talking about the main topic for today. We are about to start the discussion about this SDK. What is SDK? This is the development kit for the developers, which is based on Python. Okay, and the main idea or the main use cases for this SDK is to allow developers and people who are working in the implementation, okay, to in a flexible way to train models either locally or using cloud resources. This cloud resources could be Azure compute resources or any other resources, okay? And also the SDK gives you the capability to manage the whole life cycle of your data. You can actually upload data to a blob container in the Azure storage, okay, Azure storage account. You can actually register this as a data set in your machine learning workspace. You can make versioning on this data to make sure that you are keep tracking of the changes on this data set. All of this, you can do it from the code from Python SDK. And the third point is operationalize the trend model. Operationalize here means moving this trend model to the operation in production environments, okay? This is also part of what SDK is offering us by easily deploying them as a RESTful service. And this RESTful service, as we said before, once it's a RESTful service, it could be consumed by any client application, okay? Because it's something standard service that any application can consume without any restrictions in this case. And finally, automating the provisioning and management of the compute resources. What does it mean? When we are talking about the training phase or even the deployment phase, in both cases, this model or this training phase has to run on a specific compute. This compute could be a virtual machine, could be a cluster of different nodes or cluster of virtual machines. Eventually, we need this kind of compute to be there all the time in order to execute the experiments and execute the training phase to get finally the train the model. And as many of us know that when we have a huge amount of data, specifically if we are training a deep learning model, we have a huge amount of data. This data could be many gigabytes or terabytes, okay? That include images, include sound files, include videos, and so on. If we're gonna train such model, we need huge power and huge compute. Maybe it has to be also GPU accelerated. In that case, you can manage this kind of compute resources, and either starting from provisioning these compute resources and managing the scalability of these resources as part of the SDK as well, okay? These are the main use cases that the SDK is covering here. Now, let's talk a little about the building blocks of the SDK, okay? I will try to be quite fast here because there are too much details about the SDK itself for sure, and we are not expecting that in these few slides that we are going to cover everything, but the main point here I'm trying to achieve to give you the high level structure for the SDK, okay? And from that high level, you can start later on diving through the resources with this high level idea about how the SDK is structured to get more details, and it will be more easy to you later to do that through the documentation or Microsoft Learn or any other resources, okay? So we start all the time from the workspace. The workspace is the foundational resource. This is the main container where all of our work is lives in. So when we talk about the workspace, we said the workspace has all of our assets, has all of our experiments, has all the models that we are training, and also has the pipelines or the endpoints also that we are producing from these trained models. We actually saw this workspace many times in the previous sessions. This workspace now in the SDK is a class. This class, we can use it in our code to manage the workspace and to get information about the workspace and even to create a new workspace. We're gonna see this in the demo for sure, but this is the idea of the workspace. It's a very, it's a synonym to what we have seen in the Azure portal before. After that, we have experiment. In the experiment, we have this experiment as a boundary for all the trials we are trying to do. When you train a machine learning model, it's an iterative process, as we said before. So you have multiple trials until you come up with the final model, which fits to your needs. So in that case, these kind of trials, it's actually within a collection. We call this collection experiment. In the SDK also, we have the experiment class where this represents a collection of all trials we are doing in a specific machine learning task, okay? Then we have the run. This run also yet another class where we are talking specifically about a single trial. Within the experiment, we have multiple trials. Within the run, we are talking here about one single trial. One single trial mainly is one execution of our machine learning task, okay? This is the definition of the run. In the run, we can monitor the execution of the trial. We can see how our training phases is moving on. What is the progress of the training? We get good results over time or not, and so on. And finally, once the training job is done, this run object will store the output of the trial and also the metrics, the generated artifacts, the final trained model in a specific format, so we can download it later either from the SDK, using the SDK itself, or from the Azure portal, and so on. Okay, this is the run. If we also see this slide, we have two things here: the model and the compute target. Model is also another class in the SDK, which is representing the machine learning model itself. And using this model class, we can actually register our model. What does it mean to register the model? Registration of the model means while we are doing the training phase, once it's done, we can actually take this final model and add it to a store in the workspace where this model will be saved, and we can get this model at any time later on, and we can deploy this model later on. And moreover, we can version this model, which means that we are giving a version number to this model. So if we are running multiple experiments or multiple runs within the experiments, if we get better results in the next model, okay, we can compare between the different version of the same model and see, if we change the machine learning algorithm itself, we get better results or not, how to make this benchmarking or this comparison by having multiple versions of the generated models. And this versioning will help you to eventually come and compare what is the best results you can get from the different models, okay? Or the different versions of the same model. For sure, when we register the model, we give it a name, and by default, it gets a version. If the name of the model already there in your workspace before, and you try to register the same model with the same name again, it will get a new version, okay, incrementally by default. This is the default behavior in Azure Machine Learning. And also here, we have the compute target. In the compute target is abstraction of the compute resource, a virtual machine or a cluster of nodes, which we are using to execute the training job or the inference job, okay? Inference job here means, as we said many times before, it's the prediction job or the prediction service, okay? This is the compute target, and as we said, it's an abstraction of the place where we are executing this training job or this inference job. We have also something called run configuration. Run configuration, it's a configuration settings to identify or specify what is the type of the compute resources we are actually planning to provision or to use for this specific project or for this specific task. What is the size of the virtual machines that we need? Do we need GPUs accelerated compute targets, or no, we just need normal CPU VMs or machines? It depends on the case and the project that you are trying to implement. And also we have something called script run configuration. This script run configuration is configuration related to the training script itself. When you train a machine learning model, you prepare your training script, and this training script, you have a kind of configuration to associate between the compute target configuration and this training script. So you just give like a directions that this kind of training script will be running on this kind of specification in the compute target, okay? And we have environment. This environment is the specification of the Python packages. If you work with Python before, you might know about the Python environment. We have something like Anaconda, and in this Anaconda, we can create a virtual environment. Within this virtual environment, we start installing specific Python libraries or Python packages, which is the dependencies that our work will need. For example, if my training job will need TensorFlow, or I need some visualizations using any specific library, in that case, I'm going to create a virtual environment. And this virtual environment, I need to install all the libraries that I need in my work, like TensorFlow, Keras, and many other libraries which I need in my work, okay? And we see some concrete examples when we go to the demo as well, okay? So in a nutshell, this environment is the bundle of Python packages and the environment variables and the different software settings that you need for your machine learning task. We have also the pipeline. What does it mean, the pipeline? The pipeline is a sequence of tasks, and each task or subtask is a step. We consider this as a step, okay? So if you have a sequence of steps, this will compose something we call it pipeline. Within this pipeline, we can make all of the stages we have in the machine learning that we discussed before, like data preparation, we importing the data, we start cleansing the data, okay? And we have also training configuration to identify the different parameters that we need, the different metrics that we actually need during the training phase, and how to benchmark our model, how to evaluate the model. This kind of configurations, we do it actually also maybe as a step within a pipeline. And then we go to the training. Then once the training is done, we can get the artifacts or the final outputs and deploy the trained model in a production environment, and then publish this pipeline to be exposed as a web service, okay? All of that, each step of those, it's a step within a pipeline. So if we have this sequence of steps, that will make something, we call it in the SDK a pipeline. If we go here, you can see that also we have something called in the SDK Python script step. This is the most common step that we can use in the SDK, where you define specific train script. Okay, for example, let's say that this is the training step. And actually, I put the script name, and this script name is a reference for another Python file where I'm implementing how the machine learning model will be trained. Okay, so once I'm defining this step, okay, I can go later here, and if you look to the second screenshot in this slide, you will find that I'm defining using Python here something called pipeline, and this pipeline is running within my workspace, my machine learning workspace, and starting here I started to listing the different steps within this pipeline. So I defined a pipeline with one single step, which is the training step. This is one example how you can build a pipeline, how to define steps within the pipeline using the SDK. We have also, if for anyone who attended the last session, we talk about the AutoML, the automated machine learning, where you don't need to have any experience in machine learning, but you might have some basic knowledge, but you have a specific problem that you might be expert in, and you want to solve this problem of machine learning. You can go to Azure Machine Learning and start building automated machine learning experiment by specifying some parameters, right? Here also in the SDK, you can do the same, but using the code. So if you are a developer, if you have any development background or technical background, you can use AutoML config to configure and to define automated machine learning experiment using the SDK. And in this AutoML config, you can define what data you're going to train your model on. What is the task type? Is it classification problem? Is it regression problem? Is it time series forecasting and so on? And what exactly the algorithms you want to use, and how many iterations you want to the automated machine learning to go through, and what is the accuracy metric or the metric that you want to benchmark on, how many number of cross validations if you want to evaluate your models, and what compute target you are planning to use for this experiment. Okay, this we have something common in the SDK called AutoML config. We can use this AutoML config, as we can see here in this example, to define the different parameters for a specific run within the AutoML. This task is a classification, for example. This is the input X. This is the output Y. This is the number of iterations where our algorithms will run. So here I'm specifying these parameters, and once it's defined here, I go and run experiment, define an experiment, then submit this experiment or submit the training job within this experiment. And finally, once we are done with the experiment run, we get what we call it the best model of this automated machine learning. Okay. We have finally the model deployment. This model deployment where you can use Python also to take the final model and deploy it as a web service. This also you can do it from here, and you can rely on something called inference config and deployment configuration. These two configurations actually is required. The first one is required to define how you are going to score the inputs coming to you using the trained model. So there are some transformations or some preparation for the data you get from the user, and then you give it to the trained model to get the prediction. This kind of configurations, we call it inference configuration. And this deployment configuration is what are the compute resources you are planning to use in your prediction environment. Here, for example, in the deploy underscore configuration, I decided to use one CPU core with one GB memory, okay, as a compute resource for this inference or for this prediction service. And finally, we are deploying the model as a web service. We get the web service name, and we can get the URL and use it anywhere, okay? Now, let's go to the demo where we are trying to map between what we explained here in this presentation and what we have in Azure Machine Learning portal, okay? Let me jump here to Azure portal. I think now the Azure portal is shown. So here we start as usual from the machine learning workspace. This is our machine learning workspace in Azure, which I created before. And if we launch the machine learning studio, we come here to this overview page or the home page of the machine learning workspace. Within this workspace, we have our assets. Our assets is all about the data sets we have, the data we have, the experiments, the models, the pipelines, the endpoints. Endpoints means the web services we created from these models, okay? And we have the compute resources that we talked about before, and we have the environments, which is still in review now, okay? But the most important and the main topic for the SDK is the notebooks, okay? When it comes to the notebooks, you can see it's the first item under author on the left side, okay? If I go and open the notebooks, you will find here the files. These are the user files, and we have some folder structure here, and we have something called samples. Okay, let's explore a little the notebooks. In this samples, you have tutorials. These tutorials, it's something to help you working on the notebooks and understand the Azure Machine Learning SDK and so on. Okay. So if you want to start from these samples, for example, you can come here under the tutorials and start picking any of the tutorials you are interested in. And on the 3 dots on the right side, just go here and clone. That cloning actually, because if you open it right away from here, okay, this is a Jupyter notebook. We call this Jupyter notebook. In this Jupyter notebook, we are writing our code, and you can consider it as a development environment for yourself. So once you have a machine learning workspace, you have already the Jupyter notebook available. You don't need to set up anything. You don't need to configure anything. However, you still have the flexibility to run all of these things on your local development machine. So if you don't want to work here within machine learning workspace within the Jupyter notebooks, you can have your own virtual environment on your machine and also work with the Jupyter notebooks using maybe you prefer Visual Studio Code. You can work from Visual Studio Code, and you stay connected to your machine learning workspace here to run all of the experiments and manage all the compute resources. So the development environment here, you have a variety of ways to deal with this machine learning workspace, either from the local machine or from here. But this actually saving time because you already have the Jupyter notebook where you can start right away writing the code and make the experiments. Okay, back to here, this tutorials, we have a bunch of tutorials. As we said, if you open this tutorial, actually here, you cannot run it or execute anything. You can just read. But if you want to, for example, get this Jupyter notebook and start working on it, you have to come here, as we said, on the folder and clone. Once it's cloned, it will be copied automatically in this part in the under files under your account. And once you open, you will be able to see that the Jupyter notebook is executable, and you can start running the code cells within the Jupyter notebook. First of all, what is the structure of the Jupyter notebook? Structure of Jupyter notebook, it has 2 types of cells. The first type, we call it code cell, where you can write code and execute that code, okay? Like this one, for example. That's why you have here execution button or run cell, where you can execute this snippet of code. And you have another type called markdown cell. What is markdown cell? Like this one. This is actually where you can start writing descriptions for your coding, for your implementation. So let's say that you are working in a team and there are many team members working on the same project. And this is usually what we have in real world, in reality. So we can share the ideas and the descriptions and the notes, comments, etc. as part of the same Jupyter notebooks we are working on. So simply I can come here and start writing the markdown. Okay, it's just a text to describe something about what we are implementing here. And once I'm done writing, okay, like this, for example, if I click Control Enter, that will be saved as a text, okay? And the same here for the code cell, either to run cell from here, from this green button on the left, okay? Or just click while you have the focus inside this cell, Control Enter, okay? That will also execute the code cell. So this is simply the Jupyter notebook, either code cell or markdown cell, okay? If we go back to the files again, I already have some demos here, and our demo for today is about digits recognition. We have a very famous data set called MNIST, okay? This MNIST is all about handwritten digits, where we have like 60,000 handwritten digits in photos and pictures, and we need to build a classifier. This classifier will recognize the handwritten digit and actually output what is the digit in the photo, okay? This is a simple example, okay, for sure, but you can build on this example to understand the different components and the different building blocks of the SDK, okay? So if we start from here and go to demo 2, in demo 2, we have two Jupyter notebooks. We have other files. We'll talk about these files later, but in general, you can notice under demo 2, you have either YNB, which is the Jupyter notebook format, the file extension for the Jupyter notebook, or Python files, okay? I have two Jupyter notebooks, as we said. The first one is the training Jupyter notebook, where we are training our model. And the second one, called deploy model ACI, where we are take this trained model, okay, for the digit classification and deploy it as Azure Container Instance, okay? So we will start from this Jupyter notebook. If you saw here, we have this is the data that we have, okay? We start from importing our libraries or packages. This is Python packages or the Python libraries that we need here. If you can see, we have Matplotlib. We have also NumPy, as usual. We have something called Azure ML.core. This Azure ML.core, this is the main meta library or meta package that we are relying on here to import all the classes like Workspace, Experiment, Run, and so on. If you look here, also we have imported the class which is called Workspace. This is the foundational resources that we talked about before. And we are printing here. Let me make this quite big. And by the way, also we can just come here to this editor and open it in another window just to make it in full width to have the font size clear. But before doing that, I want to point out something here. This Jupyter notebook is running on a compute resource, compute instance. This compute instance is actually here. If you go here and open this compute instance, you can see that we already provisioned one VM here. And this one VM is the compute resource that we are using to run our Jupyter notebook, okay? Back here to the editors, I can go and open here either in VS Code, as we said, so you can run this Jupyter notebook from VS Code on your machine. You can run it from Jupyter or Jupyter Lab. If I edit here in Jupyter, you'll be able to see the full experience of Jupyter notebook. Okay, and let me increase the font just to make things clear to everyone. Again, in this first code cell, we talk about loading the necessary packages, Python packages that we need, and let's focus on those specifically, importing Azure ML.core and importing the Workspace class. Because all the implementation here starting from the workspace. Then we are loading the workspace. In this cell, in the second cell, first line here, we have one static method called from_config. Okay, what is from_config? This is actually loading the workspace which we already created before. If I don't have a workspace for sure, I can come here and create a new workspace. Okay. By just writing create, okay, create. And here you start putting the required arguments like the name of the workspace, all the parameters required, which you can actually get it from the auto completion here. Okay, so here from the auto completion, you have one nice feature here in the Jupyter Notebook. If you just click Shift Tab on this specific method, for example, or a specific object, you will get very nice help about what is the required parameters that you need to create a workspace. If you see here, you can see that we need to provide the name of our workspace, the subscription ID, if we have authentication here, some authentication requirements or not, resource group, what is the name of the resource group that we are going to use to host this workspace, what is the location of this workspace, where we are going to host this workspace. We have many regions in Azure, so we need to specify which location we are interested in. Otherwise, it will take the same location like the resource group. What is the SKU? This is the tiering, the price tiering or the price tier for the workspace itself. What is the tags? This tags is like some small descriptions for this workspace. What is the storage account, the key vault, etc. So many of the argument parameters which we can configure if we need to create a new workspace. But in our case, we don't need to create a new workspace. We actually have the workspace already, and we just need to load the existing workspace. Here, I have from config. This from config is automatically go and look for file called config.json. This config.json contains the main definitions of the workspace. From where can I see this config.json? You can go here in the overview page of the machine learning workspace. You will find here right away something called download config.json. Okay, this download config.json, it will download this JSON file, and when you open this JSON file, you will find actually the main information, which the name of the resource group, which contains the machine learning workspace, the machine learning workspace name itself, which in our case we call it ml-space, and our resource group name is ml-sdk-rg, and the subscription ID, Azure subscription ID. So these are the three properties, okay, that we have within this config.json file, okay? And because we are running here locally within the VM that hosts our Jupyter Notebook, we don't need to actually go and specify config.json here manually, okay? It's not required. You can do that, but it's not required because by default, from _config will go and check on the root, and it will find the config.json file available already, and it will pick all the values to create an instance of the workspace. This WS is instance or object of the workspace, and once we have that, we can print the information about the workspace. This very simple print function in Python, and within the print, we can just show some properties like we have the name. We have actually here also, let's say that we need to check here about this one. We can see also in the documentation some information about this print method, and if you doesn't remember how to use a specific function or method in the Jupyter Notebook, once you click Shift Tab, you can get this help, and this is also a good way to work within the Jupyter Notebook, because usually you never remember every single parameter, and you need all the time a guide to see which missing parameters you have to provide if you get any errors while executing a code cell. Okay. Here also we have, after printing the name, the location, the resource group name, as you can see here, we can see the information has been printed in this output. And we have here the experiment class. We are going to create an experiment within our workspace. So we are passing here in the argument list, we are passing to the experiment the name of the experiment which we defined here. And we have the workspace itself, the instance of the workspace, and we get this instance of the experiment, okay? Once we have this experiment, let's execute the cell. Now we have the experiment. I'm importing here the compute target, which we call it AML compute, Azure Machine Learning Compute, okay? We have the two classes actually imported, compute target and Azure Machine Learning Compute. And by the way, Azure Machine Learning Compute is a derived class or extension to the compute target. So the compute target is the base class, and AML compute is extension or another class driven or derived from this parent class, okay? What is the catch here? In this code cell, it's all about creating the compute resources that we need. So to run our classification or our training job, we need to define some cluster of nodes, compute resources. Here, if you notice, in this line, I'm just give a name to this compute resource. This is the name of my compute resource. And this resource has minimum number of nodes, 0, and maximum number of nodes, 2. So this means that I'm going to provision a compute cluster of 2 nodes, and this cluster will scale down. If there is no training jobs at all, that cluster will scale down to 0. So there is no executions, there is no cost you need to pay if you are not running any training jobs. If you have training jobs running, automatically that cluster will actually turn on or wake up the nodes to make the enough compute resources required to complete this training job, okay? But the maximum here is 2 nodes. So this is the specifications in these 3 lines that we are specifying here for our compute cluster. Once we define the compute cluster, we also here define what type of resources we need. So the SKU or the price tier, we specify something called standard underscore D2 underscore V2. This is simply how many CPU cores and how much RAM, how much memory you need in this new provisioned VM or each node within the cluster. So this is actually the specifications of the resources, okay? Here in this block, we check if we have this compute cluster. In this check, if we have this compute cluster that we provisioned before with the same name, we are going to skip this whole part, and we are going to proceed. No need to create again because we have the same compute cluster created before. If we don't have it, we start here in the else part, creating the compute cluster, okay? So we define something called provisioning configuration, which we give it the same parameters we set here, like the VM size, minimum number of nodes, maximum number of nodes. This is the configuration. And then we call compute target.create. This compute target.create simply is executing these configurations and start creating the actual cluster itself, okay? And once it's done, we can get the information about our provisioned cluster nodes, okay? Here, this JSON output is giving you an idea about, okay, the provisioning of the creation of these compute resources is done, and this is the output that you get from this provisioning, okay? In this cell, so we are done with loading the workspace here, defining the experiment where we are going to start running our training jobs within. So any training jobs is running within this experiment. We also have the required compute resources where we are going to submit our training jobs to these compute resources to be executed there, okay? And we come here to the dataset step. This dataset step is our data, okay? What data we're gonna use for this experiment, for this machine learning task? We said it's handwritten digits, which we need to recognize. And once later on, we give to our model an image which has a handwritten digit, automatically this machine learning model will be capable to predict what is the digit within this image, okay? So what is the data? It's MNIST dataset. It's an open dataset within Azure, so you can just grab it and from the open dataset in Azure and download this to the data folder here, and then register this dataset. You remember we talked about the registering the dataset in our workspace. In this part, we are registering the dataset with a specific name. We give it a specific name that we can recognize later. We give a description, and we say here, create new version. Create new version means that if you have already a version there of the same dataset, I need to create a new version of this. So it will not replace an existing version. It will create a new version for the MNIST data. Once I have this data registered, by the way, all of what we are doing from here, you can monitor the behavior in the Azure portal as well. So if you go here, you can see that I registered dataset called MNIST dataset. This is the one that I just created from the Jupyter notebook. MNIST underscore open dataset. This is the same name that I give to this dataset in my Jupyter notebook, if you remember. So you can, after executing your code cells here in the Jupyter notebook, you can see from the author part here, as the assets part here, the different artifacts, like the registered datasets, the created experiments, the pipelines, if we have any pipelines, the registered models, and the web services. So, for example, we created already an experiment called digit classifier. This digit classifier, we have it here, and it has one run inside. Okay, one trial has been executed within this experiment, and we have another experiment has been created before from another Jupyter notebook called the tutorial-sklearn-mnist. So all of these experiments are listed here, and you can see the same experience right away from the assets section under your Azure Machine Learning Workspace. Once we are done with the data, so we loaded our data. Okay, but here we register a data set. In this part, we are loading the actual data itself to load the data from and segregate the data to train and test. We explained the idea before for the train test split. If you have a data set, usually in order to train a model, we split this data into two parts, training set and test set. Maybe it's 70-30%, 70 for the training, 30 for the testing data. And why we need this testing data? We need this testing data to be used later for evaluating our model. So it will be a hidden part of our data that the model cannot see during the training phase. After the model gets trained, I will start using this test data, which is unseen data to the model, to evaluate the model and see how the model will actually predict the unseen data. And based on the results we get from the test data, we can see if this model is doing well or not, okay? In this part, you have xtrain, xtest. Xtrain is the training dataset. Xtest is the test dataset. Here, I have one folder which contains the images for the training dataset, because remember that our training data is all about images, which has the digits, handwritten digits. And here I'm getting the numbers of the digit. Actually, this digit in the image is grayscale, so it has numbers from 0 to 255, okay? And we divide these numbers in the image by 255 to normalize the pixel values. We have the pixel values from 0 to 255, but because we want to make normalization for the values to make sure that the high pixel values will not dominate the train the model while doing the training, these high pixel values will not affect more than the lower pixel values, the model that we are trying to train. As a best practice here, we come to the X-train, the training data and the test data, and do this step to make a normalization. What this step will do, it will convert the pixel values from 0 to 255 to be a scale from 0 to 1. So all of the values will be within a specified range, small range from 0 to 1. Okay, this is one transformation step, simple transformation step we are doing here. And we have Y train and Y test, where we actually just get the number. This number is from 0 to 9. These are the digits, okay? So what we are predicting from this model, what we are going to get from this model as an output, either 0, 1, 2, 3, up to 9, okay? This kind of problem we call it actually multi-class classification. It's not a binary classification, 0 and 1 or yes or no. It's a multi-class classification because the output of the model will be one of multiple values, okay, or one of multiple categories, okay. Here in this part, we start actually make a kind of exploration or exploratory data analysis, simple exploration of the data itself to see how the pictures, how the photos actually looks like. May we need to tweak something. May we need to make more cleansing on the data. May we discover that these images has some noise and we need to apply some filters on these images to make it cleansed enough for the trained model. Because if we give noisy data to the model while doing the training, we cannot expect too much from this model, okay? So in our case here, in this part, we use Matplotlib Library to show sample of the data. And as you can see, this is our data. It's a 28 by 28 image, okay, which has the handwritten digits. And you can see here that it's some of these images actually is quite confusing. You cannot recognize well, okay, maybe this is a 7, this is 3, something like that. So we expect also that the model maybe get tricked by a few images in the training data, okay? Then we go here and prepare the training script. The training script here actually is the place we start defining which algorithm we are going to use. So here I'm importing from sklearn, scikit-learn. It's a very famous Python library for the machine learning. And by the way, I encourage all of you to go here to the scikit-learn. This is the official website for scikit-learn library, and start exploring here the examples, the user guide, the information. It's classified already by the main categories or the main types in machine learning: classification, regression, clustering, dimensionality reduction, and so on. And all of these sections has examples. So it's a great learning resource. So I encourage everyone to go and check scikit-learn. This is actually a very important resource in the machine learning field, okay? So from the scikit-learn, I'm importing another from the linear model module actually, or package, okay? We are importing a class called Logistic Regression. What is Logistic Regression? It's a classifier that we can use to actually train this model, okay? So in the Logistic Regression, I am start fitting the model using the Logistic Regression with the training data to get the final trained model. What is the steps here? I have here this part, import job rep to use it later, as we will see, to dump the trained model as a Pickle file. This Pickle file format is a persistence mechanism just to save the final model in a specific file, so you don't need to repeat again what you have done. Once you are done with the training, you get the file, save it as a Pickle file using the job rep, as we will see, and you can download it to your machine and deploy it somewhere else. So it makes the trained model portable, okay? And here from Azure ML.core, we are importing the run. The run is a training job execution or an instance of the training job execution within an experiment, okay? And we have a utility file here where we have one function called load data, just to load the data. And then we have something called argument parser. This argument parser is all about specifying what are the external parameters that we are going to provide for this training script. We specified here two parameters. We specified data folder. So this is all about the location of the data, the training data, okay? And here the regularization. This regularization is a parameter we specify as an input for the training script. And what is the regularization? It's actually something we use as a hyperparameter in the machine learning to protect against overfitting. What is overfitting? Overfitting is believing too much in data. If I said that my machine learning model has overfitting, this means that that machine learning model is follow the training data, even the noise within the training data. And eventually, if we have this situation, when you go to the unseen data, the new data, because our trained model learn also the noise within the data and follow each point within the data, eventually this trained model will not be efficient enough for the new data or the unseen data. That's why we use the regularization as a hyperparameter to protect against the overfitting, okay? So these are the two parameters here. We pass it externally just to give flexibility to the training script. And then we again load the data, training data, test x-train, x-test, y-train, y-test, okay? And this is the normalization step that we talked about before. We are printing here the shape of the data to see how many rows we have in the data, how many columns, okay? What is the shape of our data? This is also important, especially if you get errors while doing the execution, just to understand why you get errors, okay? And then we define an instance of run class. We get run object. This run object is what we are going to submit to our experiment later, okay? And here the definition or the instantiation of the logistic regression. In the logistic regression, if you notice regularization term that we talk about for the protecting against overfitting, and we have some other parameters like random seed for reproducibility. We have something called multi-class auto, okay? These kind of parameters, if you need to see the definition of every single parameter, you can just go here in the scikit-learn and search for logistic regression, and you can get the definition of all parameters here, okay? What is the C parameter? What does it mean? What is the binarity? What is the kernel? What is the class weight? What is the random state? And so on. And what is the solver, okay? These are the different parameters that we can see here in our definition, okay? So the most important thing for us is regularization that we already defined, okay? And we have the fitting step. Here in the fitting, we are starting the actual training by providing here two parameters, x-train, y-train. So we give the input and we give the corresponding output, which is the numbers from 0 to 9. So we tell the model, this is actually the image, which is all about pixel numbers. And we tell the model, for each image of those, this is the corresponding number from 0 to 9, okay? So this image is corresponding to 9, this image is corresponding to 7, and so on. This is the fitting part, sorry. And then we are printing the evaluation or the score. So we are using the classifier that we trained here to predict the x-test, underscore test. This x_underscore test is the part that we hide from the model, which is the unseen part of the data. And once we get y hat, this y hat is the predictions, okay? Once we get the y_hat, we can compare the y hat to the actual y. Here, y hat is the predicted digits, the predicted numbers from 0 to 9 that the model produced, and the y test is the actual ones. So we compare the predicted digits, how the model predict this image. Is it 0 or 1 or 2 and so on? And what is the actual corresponding number that we have in the unseen data? Once you compare both numbers, you can calculate easily the accuracy of the model, and this accuracy will help you to make assessment or evaluation if this model is doing well or not. Okay. Once we are done, we come here to this step that we talk about, which is job.rep.dump, where we are taking the trained model and save it, serialize it as a pickle file. We give a name here to this pickle file, which is sklearn_mnest_model.pickle. Okay, and then once we are done with this, we have the trained model already saved. We can go to the inference part, the prediction part. If you already have a trained model, what is the next step? The next step is to go and make a prediction of this model. Okay, we have one part here related to the environment, and as we defined the environment before, this environment is all about what Python packages and libraries we need, because when we submit this experiment, actually, this experiment will be running on a Docker image. It will actually build a Docker image, and this Docker image, it will instantiate a new container, Docker container, and this Docker container will be running on the compute resource. Okay, within this environment we define, okay, these are the dependencies, these are the Python packages that we need, because we know here that during the training we need scikit-learn, we need pandas, we need numpy, we need matplotlib. Okay, these libraries is a prerequisite now to create these prerequisites. We actually create this as an environment, and this environment, when we build this Docker image, automatically this Docker image will include all of these packages installed. Okay, this is the environment part. Then we have the last part is defining actually the different moving pieces, which is the script run configuration. You define here this train.py, which is the training script that we defined in this code cell. We pass this Python file as a script, as a parameter here in the script run configuration, and then we also pass the value for the compute target. Okay, and we specify also what is the script folder where the job will pick from. So this script folder contains the train.py, okay, and also contains the YAML file, which include all the definition for the environment variables and the prerequisite libraries that our training job will need, as we said. So you define here the environment, we define the compute target, we define the training script, and then we take this configuration, pass it here to the submit, experiment.submit, to submit a new run execution within the experiment. Once it's submitted, it starts the actual training. And if you go here, let me go and run all above. Run all above, what it will do, it will run until this point. Okay. See, this is now executing. If you see this asterisk, it's executing. It's moving, yeah, it's coming here, it's executed also. Now we are here, this is executed as well. Let me execute this again, it's executed. Now let me submit the experiment run. Now it's submitted. If I go here and say, okay, I will need to monitor the training run, okay. So using what we call it Azure ML widget, we can start seeing in the real time what is the progress of the training job, because usually the training jobs in machine learning takes time. It depends on how much data you have, what is the complexity of the implementation you are doing. Here, this interactive widgets help you to see how the run is progressing. What is the progress of the training job? Here it's the status, as we can see, it's queued, so it's not started actually yet. Then after a while, you will see that it's moving actually to the next step, which is actual execution, building the Docker image, creating a Docker container, then start the actual training job itself. And once it's done, we can see here the output of the experiment run. this output will be what is the accuracy of the model and what is the artifacts we have. The main artifact or the main output that we have of this will be the Beckel file that we talked about. And this Beckel file will be saved here. If you go here to the workspace, you can see here from the experiment, from the previous runs that I have done, you can see one of the existing runs, for example. These two are queued, as you can see. I have two completed runs. Let me go to one of them. I can go here and check the output and the logs. If you notice here in the output, what we have the Beckel file. This Beckel file is the serialized version of our trained model. I can go here to the three dots and just download the file. You can take this file as a local version, and then you can deploy it somewhere else in a production environment, okay? Once you have this training done, we're gonna move actually to the last step, which is when we go here to this notebook, we have another notebook called deploy ML model to ACI, Azure Container Instance, okay? If you open this Jupyter notebook, just for convenience, let me also open it in Jupyter notebook as a separate window. Quickly here, you can see that again we are loading the required Python libraries. Then we are defining the scoring Python file. In the first part, we defined the training script, which will take the responsibility of training the model or fitting the model using a specific algorithm to our data. In this scoring script, we just need to define what is the mechanism that we need to implement for getting predictions of the ready model, okay? That's why if you notice here, we right away have initialization method here, or initialization function, which is simply just load the Beckel file for the trained model. And we have another function here called run, which takes the input, which is the raw data. The raw data in this case will be the image, okay? And this image is array or matrix of pixel values, as we said. And then simply it goes and make a call to model.predict and give it the data. And then get the prediction. This prediction, we return it from this function simply. And then we display the final prediction based on the given data. This is our script, our scoring script, okay? So nothing fancy here for this scoring part, because simply we just use the model that we have. Once you have this score.py for the scoring, okay, you come here and you remember the configurations we talked about, which is the inference config and the deploy configuration. Here we define what is the resources we need to deploy our model, okay? We define here that we just need one CPU core and 1 gigabyte memory, okay? We give some metadata tags and so on, descriptions. And then we define the environment. We said many times the environment here will be what kind of dependencies and libraries we need to run our model, okay, in the production environment, okay? And then once we have the environment and we have the inference config, we pass the scoring script itself to the inference config, and finally call model.deploy. Within the model.deploy, we are bundling all of the parameters we defined before and give a name to the service. The name here is scalability-mnest-service. We will see this under the endpoints now. So if you go now and start checking in the workspace, you should be able to see under endpoints that we have scalar-mnest-service, which is deployed here now as an endpoint as a web service based on the execution of this part, okay? Once it's deployed, okay, we can go and get the URL of the service. This is the URL of the prediction service. And then simply we can go and get some test data. And from this test data, we can see and compare the predictions. For example, I will show you something here. randomly I will get some test data and I will check how many correct predictions we have versus how many false predictions. If you notice here, we highlighted here the correct predictions to be in black color, and only the predictions, the wrong predictions, will be in red color. So this is the performance of our model, and this is a random test data. If I just execute this again, I will be able actually to see something else. For sure, you will not be able to see something here if the service is not running, but yeah, it's still running. So this means that in this random run, when we did some random test data, was able to have 100% accuracy for this given sample of the 30 images that we presented here. If we run again, it will get some random data. We can see here that this image is misclassified. It's actually 4, but it's classified by our model as 6. And we can see here this is 9, but it's misclassified as 5. It's 7 by 2. It's classified as 2. So we have 3 wrong predictions here in this test data. So this is the way how can we compare and see against the unseen or the test data in the Jupyter Notebook itself. Okay. So here in this part, finally, we can see a web request. We can make a web request, okay, which we can do the same in our web application or our mobile app, where we can call this web service URL and give this as a post to the web service, put the data, and just get the final prediction. If you notice here, we are presenting here the actual label, which is 4, and the prediction is 4. This is also picking random test data. If I run this again, I have label 2 and prediction 2. It's only getting one number, 7 and 7. Here, 5 and 5. Maybe we get something wrong. It looks that we have a good model. Now we have something wrong as a random test data. The actual label is 4, but actually our model predicts this as 8. Okay, so you can see here posted URL, and as we said, this is the web service URL. This is the actual label, and this is the predicted value from our trained model. So this summarizes the story of how to utilize the SDK to cover all the components and building blocks that we talk about in our presentation. And eventually, you'll be able actually to make use of the Jupyter Notebook as a development environment, ready development environment right away in Azure Machine Learning Workspace without any need to make or create your own development machine or to make some configurations on your local machine. But as I said, you can do this as well from your local machine, either from VS Code or from PyCharm, from Jupyter Notebook itself. I have the Jupyter Notebook here for the same actually running on my machine as well, but I don't think that we have enough time to show this part. I have it here already just for sake of showing this. I'm running the same Jupyter Notebook service on my local machine, and by the way, it's opening something similar to what we have seen. And as long as you have the right virtual environment, which has all the dependencies like Azure ML-Core and all the needed libraries like this, you'll be able to execute and manage the remote resources and the remote assets from your local machine, similar to what we have done and we have seen from the Azure portal itself. So I hope that will give you an idea and a good introduction about how to work with the SDK as a developer or someone who has a technical background to make and build ML experiments and train models, deploy models, and so on. And one more thing, actually, just to give you an idea, if you want to elaborate more, you can go to Azure Machine Learning documentation. It's a very good resource to read more about and find more tutorials about what we explained today. And also, you have Microsoft Learn. Microsoft Learn has a learning modules about machine learning. If you want to filter here, you can go to the roles and you can find just filter by data scientist. Under data scientist, you will have here different learning paths. These learning paths actually has, if you open any one of them, for example, you will find many of the modules that you can start, and most of them has exercises where you can follow the steps, follow along the steps, and go and do the steps in Azure Portal or in the code to learn more and manage to understand more advanced implementations for the Azure Machine Learning SDK. I hope that was helpful for you, and sorry for the 15 minutes extra that we spent here, and thank you so much. Let me check in 1 or 2 minutes if we still have any questions. In my first lecture, okay. So my first lecture is Microsoft Azure is free to use, and we have one question here. Let me publish. Yeah, the question is saying, it's my first lecture in Microsoft Azure. Is Microsoft Azure is free to use? And if not, then how can we use for learning? Yeah, Microsoft Azure, you can create a free account. Actually, you can create an account. And this account, if this is your first time, it will give you, I think, $200 for the first time. You can consume this $200 as a credit for your experimentation, but after you have done with this $200, you have something called pay as you go, where you can just make sure that whatever you are experimenting, you delete after you are done with it, just to avoid any extra cost and not paying for something that you don't need. So this is one way. Another way, I think also in Azure, you have a free tier where you can make use of the basic pricing tiers without paying for that, because there are like free tier. But again, you can go to the cost analysis under the resource group in Azure to see if there are any expected cost or forecasted cost for the resources you are using or not. But generally, for anyone who is experimenting in Azure, the main recommendation is go and check, do the experimentation, and it will not cost you, but make sure after you are done with your experimentation, go ahead and delete the resource itself or delete the resource group. The resource group is the container of your resources. So just to be in the safe side, go and delete the whole resource group to avoid paying any costs that you don't need. This is the idea of using Microsoft Azure in general, okay? Thank you so much for your time, and thanks a lot for joining me today. And we have another session about Azure Cognitive Services, which will be full with a lot of fun next Wednesday. Please join us in the next session and have a great night. Thank you so much.